Hello everyone. Today I am going to deal with one more very important concept of terminating and non-terminating decimals. When the students are taught to represent a non-terminating decimal in the form of p by q, that is in rational form, they are taught this traditional method, but they do not understand or do not get any method through which they can check whether this representation in the form of p by q is correct or not. So today I am going to tell you one shortcut through which you can represent any non-terminating decimals in the form of p by q by using a shortcut in a matter of just 3 seconds. So all these 7 questions can be solved in 20 seconds only, whereas the traditional method, one problem will definitely take at least 2 minutes for the child to complete this process and arriving at the rational representation of a non-terminating decimal. So in the traditional method there are say about 7-8 steps, but in the shortcut there are only 2 steps. So I am going to demonstrate those 2 steps today. The first step for finding the rational representation of a non-terminating decimal is the denominator. We will find the denominator first, and the first rule states that first of all we have to find the number of digits which are repeating. So here you can see the bar is over only one digit, so only one digit is repeating. So number of digits which are repeating is equal to number of nines in the denominator. So if one digit is repeating, so we have 1 9 in the denominator. In the second problem, you can see that the bar is over 3 2. So here 2 digits are repeating. So we have 2 nines in the denominator. Likewise, you can write the first part of the denominator in every case. Here you have 3 digits repeating. So we have 3 nines. Here we have only one digit repeating, bar is only over 1, so 1 9, bar is over 1, so 1 9, bar is over 1 digit, so 1 9, bar is over 2 digits are repeating, so 2 nines. So this is the first step. Now in the second step, we have to see that after the decimal place, how many digits do not repeat. Now see, after decimal we have 7 repeating, but there is no digit which is not repeating. So the second step vanishes for this first question. Here also, after decimal place 3 2 both are repeating, so second step does not exist here also. Similar is the case here, 3 digits are repeating, no digit is not repeating. But in the fourth problem, we have one digit, this is 4, which does not have a bar over it. So 4 is not repeating, one digit is not repeating. So if there are any digits after decimal which are not repeating, number of digits which are not repeating is equal to number of zeros in the denominator. This is the second rule. So one digit which is not repeating, so 1 0 in the denominator. Here we have two digits 4 and 2 which are not repeating, so we have 2 zeros in the denominator. Here we do not have any digit which is not repeating, so second step vanishes for this. Here also there is no digit which is not repeating. So two basic steps and we get the denominator. Number of repeating digits is equal to number of nines. Number of non-repeating digits is equal to number of zeros. Now coming to the numerator part. Now when we have to find the numerator, what we do is, in the first step we forget the decimal. Like 0.7 bar, if I forget the decimal and the bar, it becomes 0.7 and 0.7 is 7. So the first part of numerator is obtained by forgetting the decimal and the bar. Here we have 032, so 32. Here we have 0459, so 459. And we put a minus sign after that. 047, so 47. 3425, 1253, 2347. So this is the first part of our answer. We have taken all the digits irrespective of the decimal place and the bar. Now what is to be subtracted from the numerator? Now see, here we have 0 before the decimal and no digit which is not repeating. So forget the part which has bar over it. What we are left, if we forget this bar, we have 0. So here we have 0. Here also we have bar over 32, so we are left with 0. So 0. Here also if we forget the bar, we have 0. So 0. Here, if we forget the bar, we have 0, 4. So we subtract 4. Here, if we forget the bar, we have 342. So 342. Here, if we forget the bar, it is 125. And here, if we forget the bar, it is 23. So this is the final answer for all our problems. In the second step, we get the final answer. So this is 7 upon 9, which cannot be further cancelled, no common factor between them. Then 32 upon 99, again there is no common factor. Here 459 upon 999. Here we can cut it. So if you find the lowest form of this, I have already found out for you, so you can find it out. So this is 17 over 50, 37. This is the lowest form of this. Then here it becomes 47 minus 4, 43 upon 90, which is already in the lowest form. Here 425 and 342, 83, 3083 upon 900, which is already in the lowest form. Here 253 and 125, 128, so 1128 upon 9. I think it has a common factor of 3, you can cut that common factor. 376 upon 3, that is the rational representation. And finally we have 347 minus 23, so 2324 upon 99. So you see, just by applying a small rule, we can arrive at the rational representation of a non-terminating decimal. Whereas by using the traditional method, you spend 2 minutes at least for solving one problem of this kind, right? So practice this rule and share with your friends, discuss with your friends, so that when you discuss it, when you tell the rules to 10 people, you get to know it in a better way. So keep loving mathematics, keep sharing, keep subscribing. Thank you.